Hi everybody and welcome back to another video in this Pygame tutorial series. Up until this point in the series, we've already learned quite a lot of new things. We've learned how to animate a character, how to make him move within certain limits of the screen, how to create a background, and how to make our character jump. Now in today's video, we're going to be uniting all these concepts and making one single canvas with all the features we learned. As you can see, the character is animated, we have a background, he jumps and is limited to certain areas of the screen. I'm pressing the left key right now and he won't go beyond a certain point, and the same is true of the right hand side. So much of the things that we're going to talk about today is things that we've learned throughout the past tutorials. So make sure to watch them first so you understand what we do today. But the emphasis of today is going to be the object-oriented approach, which is going to be important to keep the code traceable and to make sure that we don't get overwhelmed with the code when this game gets expanded on and longer and more code intensive. So I have over here a blank canvas. This is going to be the starting point of today's tutorial. So I have a blank canvas, and in addition to that, I have all the images loaded in. So this is basically all the code there is, and the images that are loaded in are stated in these few lines of code over here. And the images are in my file tree given over here. So this is the starting point, and we're going to start off by adding the background. So to add the background, we are going to simply go to the draw function, and we are simply going to write win.blit, and we are going to print the background on the surface, and the background image is simply called background. And we are going to pass in a tuple as the second argument, which is 0, 0, which is the coordinates where the image is going to be displayed. So if I am not mistaken, then this should do the deal. If I go ahead and run this again, you will see that our background has now appeared in the canvas. So that's the first easy step. The next thing we wanted to do is to implement the character animation and the movement with an object-oriented approach. And to do that, we first need to introduce a class, and we're going to call the class Hero. Hero. Now the reason why I'm calling this class Hero is quite simple, because our small character looks like a hero. So you can call the class anything you want, but that's just so you know why it's called Hero. We're going to define an init method, init, and we are going to pass in two parameters, which is x and y, which are the coordinates of where our character is standing. And we are going to now add a couple of variables which concern the walking of our character, and that is going to be self.x equals x equals x, then self.y equals y, self.velocity in the x direction is equal to 10, and we also need two more variables, which is going to be which direction our character is facing, so self.face_right. And we're going to say that face right is true. So by default, our character is going to be facing towards the right-hand side of our screen. There's no particular reason for this. You can also make it the left-hand side. I just want to make sure that our character is always facing either left or right during every single point of the game. So then we go face left and set it to false. And a final variable we need, which concerns the walking, is the step index, which is going to be the index which iterates through the images and makes our character be animated. So we've introduced the variables. Now we need to go ahead and create a first couple methods in our class. The first method is going to be the move hero method. So define move underscore hero. And it is going to take as an argument the instance and a user input. Input, there we go. And we're going to say that if the user input is Pygame dot key underscore right. So if we're pressing the right key, then we want to increment the x coordinate, so a self dot x plus equals self dot velocity in the x direction, and don't forget the colon. And if, of course, we're pressing right, we want to make sure that the face right is equal to true and face left is equal to false. Now, in very much the similar way, we want to go ahead and create another if statement for when we press the left key on our keyboard. So when we're pressing the key left, we need to make sure that we are decreasing the x coordinate because we're moving to the left-hand side of our screen. And we need to turn this around because we're facing left and not right. Okay, so that is that. And something we will be using in a moment from now is going to be the step index. So I might as well just write it in now. Don't worry about it now, but we'll get to that in a moment. Self.step index is equal to 0. So basically, when to just give you a bit of context on this index right now, the step index is the index which iterates through all these images sequentially, and of course, when we're not pressing left or right, we want the index to be set to 0, so that every time we press a key bind, such as right or left, the animation of the character starts from the first image of the images which we have, which is this for the left-hand side and this one for the right-hand side. Just to give you a bit of context, but we'll get back to that in a moment. So then after we have the first method, we need the second method in our heroes class, which is the draw method. We of course want to draw the character, so draw, and we're going to pass in 2 arguments, which is one instance and the window in which we want to draw the character. And we're going to say that if self.stepIndex is greater than or equal to 9, in that case we want to self.stepIndex equals to 0. I'll explain that in a second. And if self.face left, if he's facing left, then we want to iterate through the images which have our character facing to the left. So win.blit, so in our window we want to blit the images that show our character moving to the left. And that is an array, so we need to make sure that we pass in an index, step index, and of course we need to add the coordinates of our character, which is going to be self.x and self.y. So we have the animation to the left working. We also need it working to the right. But of course, we also need to make sure we increment the index after every while loop iteration to make sure that we animate the character. So self.stepIndex plus equals 1. And we're going to do the same thing on the other side, which is the right-hand side. So we need to adjust this and that. All right, so now just to give you a bit of context on the draw method, we have 9 images which show our character moving to the left, which is the ones I've highlighted over here. So this is one example of one, which shows our character moving to the left. And we equally have 9 images which show our character moving to the right. This is one example of them. And since we have 9 images of each, of the character moving in one direction and the character moving in the other direction, we need to make sure that as soon as we iterate through all 9 images in either direction, the index is reset to 0, because we don't have any images beyond the index 9. And so when the character is facing left, we of course want to show him moving to the left. And so we have the images to the left, which are given over here, and the index is, and then the image is printed onto the screen, which has the corresponding index at the coordinates x and y. And of course, after every while loop iteration, we increment the step index to show the next image of our character, which gives it the animation. All right, so I think that should be it for the 2 methods, if I've not made any mistakes. Yeah, so now we need to make sure that we include an instance of the class. So we're going to create an instance of the class hero. We're going to write player is equal to hero, and we're going to pass in 2 parameters, which is an x coordinate and a y coordinate, and we're going to take 250 and 290 as the coordinates. And then in the main loop, we want to first declare the user input. So I'm going to write a comment and call it input just to make it look nice. And we're going to say that the user input is equal to Pygame dot key dot get pressed. So that means the variable user input is equal to whatever keybind we press. And in addition to that, we are going to then move on to call the class method moveHero. So I'm going to write movement, and the player dot move hero method needs to be called, and it takes an argument, which is the user input. And then we need to make sure that we are indeed showing the player on our surface, and the surface in our case is of course the window in which we're drawing our game. So we need to make sure that in the draw game function, we call the method player.draw, and we do this in the window. Okay, so let's go ahead and see if I've not made any mistakes. I am feeling confident. And yeah, you see that we we seem to have a bit of a mistake. So he manages to walk to the left and it looks animated. But when I press the right keybind, he sort of slides along. That is, of course, not meant to happen. So let me just quickly see what mistake I made. Yeah, I know what the mistake is. You know, there's always something that goes wrong. So over here, we need to, of course, write elif. And if we run it now, then we should have him walk in both directions. Yeah, now it works. You can see him walking in both directions, and there's no more issues. Alright, so the next step is to make sure that he doesn't walk off screen. So as you can see over here on the left hand side, he's able to walk off screen. We don't want that happening. And the same is true of the right hand side. He can go off the right hand side indefinitely. So let's make sure that doesn't happen. To implement that, we don't need to do particularly much. All we need to do is in the move hero function, we need to make sure that the x-coordinate is smaller than the width of the window. So we're going to write and self.x is smaller than or equal to width. And on the other hand side, on the left hand side, we need to make sure that self.x is greater than or equal to 0. And of course, over here, we need to make sure, oh yeah, I forgot that it's win_width. That should make sense now. I'm going to need to add and over here. So now all we've done is said that the movement to the right is only legitimate if the character is within the boundaries of the screen, which on the left hand side is if the x-coordinate is greater than or equal to 0, and on the right hand side is if the x-coordinate is smaller than or equal to the window width. So let's go ahead and run this. And you'll see something interesting happen now. On the left-hand side, our character is indeed bounded. I'm pressing the left keybind, but he won't go any further than that. But on the right-hand side, something silly happens, which is he still moves off of the screen. Now, why does he move off the screen if we have written that the user input needs to be right and the window width needs to be smaller, greater than our x-coordinate? So he should not be able to move off the screen, but I'll tell you why he does anyway. So over here we have our small character. You should imagine that this sort of black square around is the window which we're using. And in Pygame, we need to keep in mind that the measurements are always taken from the top left-hand corner. So when we move to the right-hand side and the sort of small x that I've marked on top of this image collides with the boundary of the screen, he won't go any further past the screen. And if we move to the right-hand side, however, he can entirely move off the screen because the x sort of is still within the screen limits. And yeah, our character, however, can be off of the screen. So you need to make sure that there is an offset. So when we move our character to the right-hand side, we need to account for an offset that is equal to the length of this sort of line that I've just drawn there. So that being said, we're going to add an offset. We're just going to estimate it. We don't need to make it exact. I'm just going to say that the offset is about 62 pixels. So let's go ahead and run the game again. And after adding the offset, you'll see that indeed on the right-hand side, he does not go off of the screen. Now, the final thing that we still need to add is the jump. So we are going to now introduce the final function for today's tutorial, which is the jump. So define jump underscore motion is what we're going to call it. And it is going to take two parameters. One is the instance, and there's going to be the user input. Because whenever we press the space bar, we want our character to jump. So we're going to say that if the user input is equal to the space bar, so pygame.k underscore space, and the current state of our character is not jumping, so we're going to say self.jump is false, then we want to change the value of the variable jump to true. So self dot jump is equal to true. True. There we go. And if jump is equal to true, we're going to say that if self dot jump, then we want to decrease the y coordinate, because a decrease in the y coordinate means we're moving up the screen. So self dot vel y times 4, and we're going to say self dot vel y minus equals 1. And finally, we're going to say that if the character is back in the original position and he is moving downwards with the same velocity as he left moving upwards initially, then that's gonna be the finish of the jump, and we need to reset the velocity in y direction, and we're going to reset the value of our jump. So self dot jump to false, and the value of our velocity to the initial value which we had beforehand, which is equal to 10. So I don't want to go into too much detail on the jump, because we already learned a lot about it in the one tutorial, which was, I think, one of the earlier tutorials. So go ahead and check that one out if you want to know more about this jump. But just to briefly describe what happens here is that if the user input is the space button and the character is currently not jumping, then we're changing the value of our jump variable to true. And if the jump is true, then we want to decrease the y coordinate, because that means we're moving up screen. But while we're moving up, the velocity at which we move up is decreasing. And at the very tippity top of the jump, the velocity is 0, and the sign of the velocity changes and it goes downwards, right? And when we have the negative velocity of 10, which corresponds to the velocity we initially left the ground with at the beginning. So at the beginning we leave with a velocity of 10 upwards with a positive sign, and when we're moving downwards and reach a velocity of minus 10, that means our jump is finished. And we need to implement the jump in our main loop. So under the movement segment, we're going to write player dot jump motion underscore motion, and we're going to input the user input. And that should be it, if I'm not mistaken. Let's go ahead and run the code. Oh, there is an error again. Hero object has no attribute jump. Oh yeah, of course, I forgot to add a variable to the hero class, so there's going to be a name error. I'm going to include that over here, so we're going to write jump over here, and we're going to write that self.jump, and by default we're going to set the jump to false, because of course when we start the game we don't want our character jumping. So yeah, that's what we need to include. I hope that should fix the problem. Nope, there's another problem. Object has no attribute velocity in y direction. I know what that means. Of course, we need to add a self.velocity in y direction, and we're going to give it the same value as the x direction of the velocity. And now if we run it, then yes, finally we've managed to get it running. Let's see if it jumps. And yeah, the character is jumping, he's bound to the right and to the left hand side of the screen, which is exactly what we wanted. And we're going to leave it here for this tutorial. This was a bit of a reminder of what we have done throughout the past 6 videos in this series, and we also managed to implement an object-oriented approach, which is going to help us really much when the coding gets when the game gets more code intensive down the line. So if you've enjoyed this video and learned something new, then make sure to give this video a like and subscribe to this channel if you want to stay updated on the series. And as always, the code is going to be available on the GitHub, which is down in the description below.